So welcome everyone. This is the first lecture of our stereochemistry course. The lecture is titled as Basics of Stereochemistry. In this particular course lecture, actually, I will mainly focus on the why stereochemistry is important, what is stereochemistry, and its importance, and we'll discuss about the little bit of isomerism first. So first of all, let's start with our basics. Stereochemistry. The term stereochemistry, it's main about the stereo part. The stereo means the three-dimensionally. Hence, stereochemistry is often referred as 3D chemistry. Okay, and the first stereochemist is Louis Pasteur because of the tartaric acid works. So, first let us analyze that why it is called a 3D chemistry with a simple reaction. Okay, so let us take about a carbonyl group here. Okay, let us take about this type of carbonyl group, and it will react with a nucleophile in the carbonyl center, that is this center, because this center is the electropositive center. Okay, so if it is attacked here, this will go up, and after some kind of proton abstraction elimination, the final compound is something like this. H NuH. Now if you see carefully, then this particular center is earlier a sp2 center. Now sp2 center suggests that the compound is present in plane, but after addition of an external nucleophile, this particular center is no longer sp2 now, it is an sp3 center. Okay, so if it is become an sp3 center, then these four bonds are not supposed to be in the plane, because we all know that in sp3 compound the bond angle is 109.28 degrees. Okay, so that means either these two bond is planar, but these two bond is supposed to be in non-planar. Either it will be a plane towards the viewer or behind the viewer, and this actually brings the possibility of two different structure of this particular molecule. So hence it is a 3D geometry, and this the main importance in our stereochemistry, this orientation, and due to this orientation or 3D spacing arrangement, the whole concept of stereochemistry lies on this particular thing. Okay, now I just simply remove and tell you the importance of stereochemistry. Basically, stereochemistry has been shown significant importance in the pharmaceutical industry, and actually you may be wondered that in the pharmaceutically, in one of the pharmaceutical cases are very famous, that is the thalidomide disasters. Actually from there the people has understood the importance of stereochemistry. Okay, so what happened, that this is the thalidomide species. Now here you can see that this particular carbon and hydrogen this particular carbon is a sp3 carbon here. Okay, this also sp3, this also sp3, but we are importing this particular because here you can see this particular compound can be stay in this two particular different structure or 3D arrangement, you can say. Okay, so what happened that in earlier case, this particular thalidomide is used for a morning sickness drug for the pregnant women, but interestingly this particular R isomers only used for a drug for morning sickness, but this opposite isomer, that is a S isomers, having tetragenic effects that causing genetic damage to embryo. Now in previous time, when the people are not bothered for stereochemical aspects, so they are giving this particular compound irrespective of their particular isomer, R isomer, S isomers. Okay, so what happened that in that particular case the morning sickness can be diminished, but the pregnant women have faced serious genetic damaged childs. So basically in that time they are actually producing the genetically damaged childs or some kind of issues, and this particular, when investigating this particular case, we have found that no, there is a significant amount of stereochemically aspects was there, where they were found that R isomer only used for the morning sickness drug and S isomer is the toxic for the body. And not only that, actually there are various drugs present in the pharmaceutical where one of the isomers have shows the medicinal properties, but the other one is shows the toxicity properties. Okay, so from this particular story actually the stereochemistry comes into the play. Although if we only give the R isomers, so in our body temperature it also produces S isomers, so that's why actually this particular drug is actually given nowadays very cautiously, and basically it will be not used for many of the pharmaceutical cases right now. Okay, now I will show you another important aspect of the stereochemistry point of view, that is the classic example of stereochemistry in daily life, that is a limonene, which can be found in orange and lime. So we already know that oranges and lime, they are two distinct characteristics shown, but interestingly those have the same molecule but in the different orientations, means different 3D orientation I can say. And you can see that just because of this particular orientational changes, okay, how the physical property of these two is drastically different. Like in orange you can find it is a sweet and orange in color, but in the lemon it is a yellow, a greenish yellow in color and little bit of sour taste it was. Okay, so I hope that these two examples will lead you at least a basic overview that why the stereochemistry is important and why the particular a small change in the stereochemistry will show the drastical changes in the physical properties or chemical properties as well. Okay, so now we are actually talking about so much about isomers, so let us understand what is the isomers is. Now first of all we are checking two different compound, or we can say the two different compound having the molecular formula. If the molecular formula is same, then we can call it as a isomers. If not, then we can say the non-isomers. In our previous example, here both the compound have the same molecular formula but in different spatial arrangement. Now these are the isomers. Now if the isomers having the same bonding connectivity, the connectivity is, I think, about a bonding connectivity. If it is the same, then it is called a stereoisomer. If it is not, then we can say constitutional isomer. Now we have further classified the stereoisomers, like if the stereoisomers having a non-superimposable mirror image, it is called enantiomers. If not, that is called diastereomers. Now you can find little bit of fishy about what is the non-superimposable mirror image, what is the same connectivity, non-isomers, constitutional isomer. I know that it seems little bit of tricky right now, but as we progress in our lectures we can found that these things are easily understandable. Just bear with me with some lectures. Okay, now let us talk about this example, because here the connectivity issue, many students face issue with this connectivity. So let us take a simple example, like two compound have same molecular formula C2H6O. Now here C2H6O can be further classified into two different compounds. These are C2H5OH and CH3OCH3. Now here the carbon is 2 hydrogen is 6 and oxygen is O. So this molecular formula is justified. But here also carbon is 2, hydrogen is 6, oxygen is O. So this particular molecular formula is justified. So these two are isomers, but is it a stereoisomers? Now here you can find that there is a 1 carbon oxygen bond present here, but here 2 carbon oxygen bond present here. Like if we draw this compound, then we can see this will be CH3O. So I am writing with the mouse, so the writing will be a little bit tricky, but I hope that you will be here. So this is the 3, okay, and it will be the C2H5OH. Okay, just write it like lucid way. So if you see here, this particular have two CO bonds, but here only CO bond and OH bond is there, so they are not having the same connectivity, so it will be a constitutional isomers. Now if we see previous case, in our previous slide, here you can see this particular two different structures have same identical bonding connectivity. Like this particular carbon also have this group and a hydrogen, and this particular group is also have this group and a hydrogen, so it has same bonding connectivity, so we can say that it is a stereoisomers. Okay, and now this is the constitutional isomers. Okay, now after that this will be further classification we will talk about later. Right now we are talking about a few terminology. So first we are talking about the stereoisomer, that in the previous chart we have understand that what is the stereoisomers. Now we can find the definition of the particular stereoisomers. So the stereoisomer suggests that molecules with the same molecular formula and same atom connectivity but differ in the three-dimensional arrangement of the atom in space. Imagine the case of limonene, like, or in the case of thalidomide, like there you can find that this particular bonding connectivity is different. Like sometimes the big group is the near about the observer, or sometime it will be the away from the observer. So the difference in the three-dimensional arrangement actually make them a stereoisomers. Okay, now there is a very important topic that I want to discuss about the asymmetric molecule and dissymmetric molecule. Okay, asymmetric molecule is a molecule that lacks the symmetry elements. Okay, like that particular molecule have no symmetry elements. And a disymmetric molecule is a molecule that lacks certain symmetry elements, such as plane of symmetry, center of symmetry, or improper axis of symmetry, or some kind of symmetry. Like completely not a symmetric molecule, like some symmetry elements are not present there. Okay, so these two we'll understand with the example, but before that, in our next class we are talking about the symmetry in brief. Okay, like you, before going for the main stereochemistry, we are looking about the symmetry part. So let us summarize that what we are actually learned in the first class. Initially we have learned the stereochemistry. Stereochemistry is often referred as a 3D chemistry because the 3D orientation actually the main backbone of stereochemistry. Then after we are talking about the limonene case, like how a subtle orientational change can lead to drastically physical and chemical properties difference. After that we are talking about the isomers. We know that isomers are nothing but a same molecules having the same molecular formula and the bonding connectivity. Like if the bonding connectivity is same, then it is called a stereoisomer. If different, then it's called the constitutional isomers. And after that we are talking about this terminology, the stereoisomers. Stereoisomers are isomers but having the same bonding connectivity but difference in the three-dimensional arrangement of the atom in space. And asymmetric molecule, that molecule contain no symmetry at all. And a disymmetric molecule, is a molecule which contains symmetry but lacks certain symmetry element like a plane of symmetry, center of symmetry, improper axis of symmetry. In our next class we are talking about the symmetry and symmetry elements in brief. So we are end this class, and this chapter will request lots of imagination, so you will practice the imagination a little bit. So we have end this class right now. So thank you for listening.